Welcome to Spring LIB.
Okay, so the setup is as follows. You have the skier on this. I'm just showing this one section of the sphere. The skier is on is at an angle theta from the top, and so there's a force of gravity acting downwards and normal force acting upwards. So if we want to resolve forces, the radial force, if you'll recall, is mv squared over r, and that will be equal to the net force here. So net force here is mg cosine theta minus Fn, or normal force. Okay, and so, okay, so this, for the critical velocity, or the critical angle theta, you want the point at which Fn is 0, right? Skier is just touching the surface, and there's no normal force yet. So Fn is 0 would imply that v squared, let's call it v crit for critical velocity, v crit squared r is g cosine theta crit, or critical angle. And so cosine of the critical angle is critical velocity squared over gr. And we'll call that equation 1. All right, then we use energy conservation. Okay, so E initial will be equal to E final. So V1 initially, there's no velocity, V1 is 0. We find the relationship between y and r as, with a little trigonometry, y is just negative if it's increasing downwards. So y is positive downwards. Y is negative, or y is increasing downwards, is negative r times 1 minus cosine theta. Okay, this is from simple trigonometry. And so y1 is negative r times 1 minus cosine 0. What is cosine 0? It's 1. So y1 is 0. So initially, you have no kinetic energy and no potential energy. Okay, so 0 equals final kinetic energy, 1/2 mv1 squared, plus final potential energy, which is mg times y, or 1/2 mv2 squared, I should say, plus mg times y2. And y2 is, again, negative 1 minus cosine theta. So we have that v2 squared is, so the m's cancel, obviously. v2 squared, therefore, is 2gr times 1 minus cosine theta. Okay. Therefore, we can substitute this in equation 1. We have is cosine of critical angle is equal to just this, 2gr times 1 minus cosine of the critical angle over gr. And so the gr's cancel. We're left with cosine theta critical is equal to 2 minus 2 cosine theta critical. Therefore, the critical angle, or cosine theta critical, is 2/3. So take the arc cosine of 2/3, and you get that the critical angle is 48.2 degrees. All right. And finally, in part B, you want to know what happens when friction force is added. When friction force is added, you have that 0 equals 1/2 mv1 squared, right? The kinetic energy plus the potential energy minus, plus work done by friction, okay? And so whatever this V2 is, there will be a subtraction in the V2 term here by friction, work done due to friction. And so V2 will go down. V2 decreases. V2 decreases as a result. Therefore, you can see from equation 1 that when V2 goes down, cosine theta crit, or critical angle, increases, goes up, and they're directly proportional. Therefore, your critical angle is larger in that case. And that's it.